That would have been, well, let me just double check. I thought I did. We said B, right?
Mm-hmm.
Okay, good. Now let's get off of the respiratory. We might come back to it, but now we're on, think blood. Where am I? 16. We're looking at, what's another name for white blood cells?
Leukocytes.
Leukocytes. Yep, okay, good. Now, which leukocytes or white blood cells engulf stuff or are phagocytic? Or what's an acronym for it?
Men.
MEN, M-E-N. Men, M stands for what? Monocyte. E stands for eosinophil. N for neutrophil. All right, good. So we have those phagocytic leukocytes or white blood cells. Basic. Which ones are the most numerous?
Neutrophils.
Neutrophils. If you have a bacterial infection, which ones would do that?
The monocytes.
It'd be the bacteria in the body. They'd be the first ones to arrive to fight this bacteria.
The neutrophils. Didn't you say neutrophils?
Neutrophils, yeah. So neutrophils, since they're the most numerous, they're going to be the first one on the scene if there's maybe some sort of a bacterial infection. Why would you have a high amount of eosinophils?
Parasite. Yeah.
Parasite, yeah. Worms.
Gross.
Worms, Roxanne. I was scared of worms. Now, what are those huge ones called? Monocytes. These monocytes can cruise around and maybe they're going to leave circulation and take residence, or they're going to live in the periphery, outside of the tissue, outside of the vessels. They're going to change their name. They're going to change their name to big eater.
Macrophages.
Macrophages, yes. Awesome. So I just told you a bunch there. That'll be for a few questions. So want me to repeat any of that? Eosinophils basically know what the white blood cells will do, why we have an elevated number. Neutrophils for bacteria, eosinophils for those parasites, basophils. We didn't talk about basophils yet, but if you have an increased basophil, you might have an allergy or inflammation,
yeah.
like an allergic reaction type thing. We mentioned that already. If I say fibrinogen, what's fibrinogen involved in? Clotting, yeah. Fibrinogen. Fibrinogen is going to get converted to fibrin, yeah. Fibrinogen gets converted to fibrin, so that's going to be involved in clotting. So if you have a lack of fibrinogen circulating through, what are you going to have a problem doing?
Clotting.
Clotting, okay. Oh gosh. How long ago did we do blood? Feels like forever. Know what the universal donor would be and the universal recipient would be. You know the universal donor, know the universal recipient. Oh gosh. Let me show you a picture for this one. I'm still on that blood one because it actually said something. Oops, wrong one. Blood. I want to get the blood types. All right. Good. Thought I was back there already. so we got universal recipient, universal donor. And I think, maybe I'm wrong. Did we do positives and negatives this year?
A little bit. Not too much.
Did I say weird? Positive and negatives, that's just tests for another thing that's hanging off of the surface of our red blood cell, the surface antigen.
Your RH.
It has to be the RH, yeah, the RH factor, the rhesus factor. If you have it, then you're positive. If you don't have it, then you're negative. So this particular one, now that I just went through all that, what number is that? 18. Yeah. Out of all that, it didn't even matter, the positives or negatives, now that I said it. I was looking at the choices, I guess I should have read all the choices before I just wasted that much time. So who's our universal donor?
Oh,
Oh, who's our universal recipient?
AB.
Yeah, okay, yeah. Positives and negatives won't even matter there. Yep, good. Ooh, what do platelets come from? These
They're
large cells
fragments.
called
Megakaryocytes.
megakaryocytes. Megakaryocytes. Because, or in other words, we could say, so we know platelets come from megakaryocytes now. Another word, how could you describe what platelets are? They're what?
Fragments.
Fragments, yeah. Cell fragments of megakaryocytes. Good. Okay, now we're switching to heart. Those heart sounds, what makes those heart sounds?
The closing of the
Valves.
valves.
What's the lub from?
The atrioventricular valves closing.
Yep, the lub, that first sound you hear, the lub, the atrioventricular valves are slamming shut, or slamming shut. Lub. That's a heart sound. Valves, slamming shut. What's the dub?
Semilunar valves.
Semilunar valves. What's this refer to? Yeah. Eminence, tibial eminence.
Yeah, that's what I was thinking.
Oh. Ooh, this one. Let me get to the heart. We'll end up having to finish this on Wednesday. This will be our last one for now. That's where we stopped. All right, the heart, with these volumes and pressures. Oh, good grief, this isn't gonna be very useful. It's very small. It's labeled here, kind of. But if I was to say isovolumetric, and it's a phase, isovolumetric, the chambers, the two lower chambers, the ventricles are contracting. In this case, it's just showing you all left side, I think. Well, it doesn't matter. The ventricles are contracting, isovolumetric. They're contracting, pressure's increasing, isovolumetric, same volume, but pressure's increasing, and then what causes the ejection? What valves crack open?
The semilunar valves.
Semilunars crack open because of that pressure, because it's a one-way valve. We want to have the blood, we don't want to, but the blood wants to go back from where it came, so it's going to go by the AV valves, but they slam shut. The ventricles are increasing pressure, increasing pressure. Blood wants to go back to where it came from, but it's saying, no, it can't. Those valves are doing their job. Pressure will increase to a point and then it's gonna blow open those semilunar valves in a good way. And then blood will eject. They call that ventricular ejection phase. Nice. But during that isovolumetric phase, isovolumetric contraction phase, that pressure's increasing and increasing inside of those ventricles. So this question is asking about the relaxation phase. Oh my God. I saw isovolumetric and I was like, yeah, great. So you can go take a peek at the relaxation phase. Oh gosh, all right. Let's end there because I gotta go to lab anyway. We'll pick up on this question again, and now on Wednesday we'll talk about the isovolumetric relaxation phase. Good. If you want a little sneak peek, go ahead and look at that for yourself. But yeah, that's where we'll pick up. We're about halfway through this, so we're in good shape.